All right, so the second part of 2.2 is solving absolute value inequalities. So yesterday when we did the equations, we talked about how there are two cases when you're solving an absolute value equation. You are going to have different cases with the inequalities as well. So when you're solving these, again, you're going to have two cases, and these can be written as what we call a compound inequality. Okay, one of the compound inequalities is going to be one long inequality. The other one are going to be two short inequalities. So here is your first case. Okay, we're going to investigate these two cases for the absolute value. Okay, so if you have the absolute value of an expression, ax plus b, and that's less than some constant c, we know whatever is inside the absolute value from what we talked about yesterday, it can either be positive, like this. Okay, this would be your first case, case 1. And then case 2, whatever's inside here could also be a negative value. Okay, so if you have a negative value and you solve this, we have to remember some of our special properties of inequalities. Okay, so you can have whatever's inside is less than c. This value could also be negative. Okay, and instead of distributing, what we're going to do is we're going to divide each side by -1. And what that would give you is ax plus b, and then because we're dividing by a negative, we flip that sign, and this would be your second case. Okay, so when these two things happen, you have a quantity that's less than a constant, and that same quantity is greater than the opposite of that. You can make that into one long compound inequality. So you have this quantity is less than c, and at the same time, it's greater than the opposite of c. And this is going to be our rule. Okay, this is our rule whenever it is less than. Okay, so the less than is going to have one inequality because the conditions occur at the same time. And I'll expand on that in a moment. Okay, so we just found our rule. The opposite of c is less than ax plus b, which is less than c. So anytime you have a less than, you are going to jump to this equivalent form. Okay, and it's one inequality because the conditions occur at the same time. So the easiest way to explain this is let's pick a value for c. Okay, let's pick 8. So if you have this quantity is less than 8, are there numbers that are less than 8 that are also greater than -8? Yeah, what are some of those? -1, 2, 6, 7, right? Okay, so those can occur at the same time. So we say and. Okay, these occur at the same time, so we can include them with an and. So if they can occur at the same time, you have one inequality. Now we're going to investigate what happens with a greater than symbol. Okay, so if you have the greater than symbol, when you're setting up case 1, you're going to have ax plus b is greater than c. And we're going to start case 2 in a similar way, where we know whatever is inside could be a negative. So if we solve this by dividing by -1, what happens again is that flip. Okay, so this is saying that it's greater than a value, and then it is also less than the opposite of that value. So is there a number that's greater than 8 at the same time it's less than -8? No. So those cannot happen at the same time. So we're going to connect them with an or. Okay, so because they cannot happen at the same time, you're going to set up the expression is greater than C, or your expression is less than the opposite of C. Okay, so your greater than has 2 inequalities. Because the conditions cannot occur at the same time. Okay, so it's an either or situation. Yeah, because these are the same as well. So what we discovered is whether what's inside is positive or negative, A to be greater than C, we can either set up this case, or if it's less than, we can set up this case. So we're just going to organize that in our table on the next page so that you can just use this when you are solving. Okay, so when you are given an absolute value inequality, you can either have a less than or you can have a less than equal to. Okay, so if you have ax plus b is less than c, or if you have a quantity that is less than equal to c, then you are going to set up your compound inequality, okay, by rewriting each of these. All right, so this would be the opposite of C is less than ax plus b, which is less than C. The only difference here is you'll have the equal to. Okay, now this is something that you're going to need to know, but that's why we're going to practice it. And if you ever second guess yourself about what your setup could be, just remember, this condition should be able to happen at the same time. And if it can't happen at the same time, then we can't have it set up in one inequality. We have to connect it with an or. So that's when we have the greater than and the greater than equal to. So you can start with a quantity that is greater than a constant value, or it really can also be an expression. And then ax plus b can also be greater than or equal to c. And this is going to be what you connect with the OR. So you can have AX plus B is greater than C, or AX plus B is less than the opposite of C. And then the same thing happens with the equal to, so you can have the equal to. Okay, so as you're first starting out doing some of the practice questions, you might want to refer back to this chart. So now it's nicely organized for us, so we can refer back to that. Okay, so we're going to solve each inequality and graph the solution set on a number line. Remember that your first step is always going to be, just like it was yesterday, you want to isolate the absolute value. Okay, so you might be able to do that first step without me based on what we did yesterday. So you do have to move something over to get the absolute value by itself. So you can go ahead and do that step. Okay, and then once you have this alone, then you want to write the compound inequality. Okay, so you can use your chart up here. So if it's less than or equal to, then we can rewrite it as the opposite of C is less than or equal to that quantity, which is less than or equal to the constant. I always start when I'm writing, I know that one of the equations is going to have this in it, right? After you've been doing this over and over again, you're going to get there. So if it's less than or equal to 7, can it also be greater than or equal to -7? Yes. If the answer is yes, you just tack it on there. All right, and then when you're solving an inequality, it's very similar to when you are solving an equation. Okay, so instead of having 2 sides, this time we have 3 sides, so I'm subtracting 5 from all of those sides. Okay, and then to get m by itself, now I'm just going to divide everything by 2. So I have -6 is less than or equal to m, which is less than or equal to 1. You can keep your solution like this. Okay, you don't have to put it in the set builder notation. And then we do have to put that on the number line. Okay, when you are graphing these on the number line and you have those key values, I'm okay if you just do -6 and 1 if you put those key values on there. Just remember that if you have an equal to, you're going to have closed circles. So you're going to have a closed circle at -6, a closed circle at 1, and then we're going to connect those together. All right, so based on that, can you guys do the first step for part B? Okay, so I just want to do the first step where you're isolating the variable, and then if you want to look in your chart to see if you can set it up. Oops, sorry, -1. Getting a little friend here. I students had these cool whiteout pens last year, and I was like, oh my gosh, I need those. Okay, so this is pointing at less than, okay? If it is this symbol, the less than symbol, it's saying that there's a number here that is less than or equal to -1, but according to this setup, I'd also have to put this on there. Okay, so you can't have that. You can't have this. There's no number that can be less than or equal to -1 and greater than 1. Okay, but that is our setup, right? According to the equivalent, a value cannot be both greater than equal to 1 and less than equal to -1. Okay, that means the solution for this is something we talked about yesterday called the null set. Okay? Okay, so we're going to say, therefore, there is no solution. Okay, it is the null set. Okay, so if your setup does not produce a valid answer, okay, no solution is going to be possible. Now, let's say you went through and you solved this. Okay, I'm just going to show you on the back. Let's say that you solved this. Okay, good. 1 is greater than 6x plus 15 is less than or equal to -1. You would subtract 15 from both sides. Get -14, 6x, -16. You divide by 6. You remember to reduce because you're awesome. So you divide by 2. Okay, and then you get x is between -7/3 and -8/3. Okay, just to help you visualize what this is, I'm going to write them as decimals because I think that's easier for you to process. So what you have is -2.3 is less than or equal to x, which is less than or equal to -2.6. Again, this cannot be true. If you were to try to graph this, okay, you should have a value that is going to be a graph that looks like this. Anytime it's an and situation, this is what your graph would look like. But if I graph this, I'd have x is greater than -2/3, and I'd have it's less than -2.6, which is not what you should have for this case. Okay, so there should be no gap on the graph for the and case, which is the greater than case. Okay, if you have one inequality, it needs to look like this or it needs to look like this. Okay, so that's just more evidence to support when you have no solution. Okay. All right, let's go to part C. Okay, so for part C, this is already isolated. You have the greater than. Okay, so for the greater than, you're going to set up two equations. Okay, so you have 5.5a plus 2 is greater than 0.5a plus 4, or 5.5a plus 2 is less than, and then when it's the opposite and you have two terms, please put them in parentheses so that you remember to distribute. Okay, so I want you to take a moment. Again, we're solving that without your calculator. Okay, and your answer should always be written as a reduced fraction. Okay, so we're getting all of our A values on one side. Okay, so you would get 5A here. And then at the same time, you can get all of the numbers on one side. So you have 5A is greater than 2. Divide both sides by 5. Fabian, we're not talking like that.
Huh?
We're not talking like that. Okay, and then once you have that set up, go ahead and do your number line. Okay, so even though these are decimals, these are pretty nice decimals, right? Because you're adding a half to 5.5, so we're getting 6. Oh, I guess I could have done that at the same time. It's too late. I already wrote it. Okay, so you have 6A is less than negative 6. Do you flip the sign for this one? No, because you're dividing by a positive. Okay, so your final answer is A is greater than 2/5, or A is less than negative 1. And then we are going to graph that on our number line. Okay, when you're doing this, just make sure negative 1 is going to go first. 2/5 is going to be positive. I have an open circle going to the right for A is greater than 2/5. I have an open circle going to the left for A is less than negative 1. And because this is an OR situation, you are going to have the gap there. Okay, so anytime you have an OR, you're going to have a gap on the graph. Okay, if you have an AND, you should not have that gap because they're two different cases. AND is going to be one case. All right, for D, can you guys go ahead and isolate your absolute value? So this is a two-step isolation. All right, so it looks like most of you guys got your first step when you're adding 13 to both sides. Okay, and if you're freaking out about multiplying by 4, let's talk about strategies without our calculator. Okay, so again, you never distribute this, okay? We're going to multiply both sides by 4. A quick way to multiply by 4 without your calculator is to multiply each by 4. So if it's 18, it's 10 and 8, right? Okay, so what's 10 times 4? 40. 4 times 8? What? How dare you say that again? I'm pretty sure he said 6, 7. We're not. All right. So once you have that, okay, now we can set this up. So it's greater than. If it's greater than, then you have 3x minus 12 is greater than 72, or 3x minus 12 is less than the opposite. So negative 72. Okay? Anytime it's greater than, you have the or. Anytime it's less than, you have the and. Okay, so we're going to add 12. Do you guys know how to tell right away if 3 goes into that evenly? Yeah, add the digits. Yeah, so 8 plus 4 is 12, so you know it's going to go in there. Okay, so how many times does 3 go into 8? 2 without going over. Okay, so that would be 6, so there'd be 2 left over. So you put the 2 with the 4. How many times is it going to 24? 8 times. Okay, and then really what I'm doing is this, but in my head. So 3 goes into 8 twice. You subtract, you bring down the 4. Good times. Okay, now when you're adding 12 to a negative, remember the number's going to get smaller. So I'll add like the 2 first, negative 70, then the 10 to get negative 60. When you divide by 3, x is less than negative 20. So then your solution is going to be this, and then we're going to do our number line. So I'm okay with you putting your 2 key values on your number line. Just remember, if there's no equal to, it's an open circle. And if there is an equal to, you are going to have a closed circle. All right, so I'm going to keep the rest of the time to 1.